So now we're going to look at derivatives of exponential functions. Our first function has a base of e raised to the exponent x. The derivative of e to the x is also e to the x. However, if f of x is e to the g of x, that is e base raised to a differentiable function, then f prime of x is e to the gx times g prime of x. So that's the chain rule. Now, if our base is anything other than e or 1, we have an exponential function that looks like f of x equals a to the x. The derivative of f of x equals a to the x is a to the x times the natural log of a. However, if the exponent of the base a is g of x, a differentiable function, then the derivative of a to the g of x is a to the g of x times g prime of x times the natural log of a. So again, it's the chain rule. So here's example number 1. Example number 1, we have f of x equals 3e to the negative 3x. So our f prime of x, for an exponential with a base of e, you always copy the function exactly as it is, and if the exponent is differentiable, you take the derivative of that exponent. So it's 3e to the negative 3x times negative 3. So I'll bring these monomial factors together. Negative 9 e to the negative 3x is our final answer. Don't forget the chain rule. Example number 2, differentiate the following function. Y equals e to the x to the 4th. So again, we have an e base. The derivative of y, dy with respect to x, can also be written derivative with respect to x of e to the x to the 4th is going to be copy e to the x to the 4th, then take the derivative of the exponent, which will be 4x to the 3rd. Now you can simplify this by putting the 4 in the front, e x to the 4th times x to the 3rd. And it does not matter the order of those factors. So the final answer for the derivative of y equals e to the x to the 4th is 4e to the x to the 4th times x cubed. Example number 3. Find the derivative of the function y equals 2e to the 5x squared. So when we take our derivative of the exponential function with the base of e, we copy the function in its entirety, 2e to the 5x squared. Then since our exponent can be differentiated, then we multiply times 10x. Clean it up a little bit, get your numbers together. 2 times 10 is 20, e to the 5x squared times x. And you could put that x right behind the 20 if you would like, or it can be at the end. The order of the factors does not matter. Our final answers, 20x e to the 5x squared. Example number 4. Find the derivative of the function y equals x to the 10th times e to the x. So here I'm going to need a product rule. So our product rule says you take the first times the derivative of the second plus the second times the derivative of the first. So my first is x to the 10th. So my first prime is 10x to the 9th. My second function is e to the x. Its derivative is e to the x. There will be no chain rule involved here because neither of our exponents are differentiable, except for x would be 1, and there's no need to do that. So we're going to have our first, x to the 10th, times the derivative of the second, e to the x, plus the second, e to the x times the derivative of the first, 10x to the ninth. So this is our y prime. Now I'm going to clean up my y prime by factoring out common factors. They both have an e to the x. They both have an x to the ninth. So I'm taking out the common factors. What would be left would be an x plus 10. So e to the x times x to the ninth times, in parentheses, x plus 10. So e to the x to the ninth times x plus 10. That is our final answer.